Trucking companies comparing two different truck routes, Route A and Route B. So they're two different distinct sections of the population, you could say. So we got two different samples. So whatever we're going to do, it's going to be a t-test for two independent samples, not a paired test, because we're not testing trucker A, the first trucker working for company 1, and then the first trucker goes and works for company 2. That would be paired because it's the same trucker measured twice. This is not paired. Okay, for 49 minutes, standard deviation of 3, 51 minutes, standard deviation of 2. Okay, so they've given us a summary of the information, then they asked us to construct a confidence interval for the difference. So let's see if I remember. You want to go to, if you want to do this in StatCrunch, which remember you can get by clicking Get More Help and then StatCrunch. If you go to Stat, and then we want a t-stat because we don't have the population standard deviations. Otherwise, we could use z-stats. But by the way, the t distribution approximates the z distribution with larger sample sizes. So the error gets smaller as the sample size gets bigger. But okay, but long and short of it is, most in practice all the time we're really using t-stats, except unless we're doing a population proportion. Okay, that's all stuff you probably didn't want to hear. So let's get back on track. T-stats, you want to go to two sample like we said. And it's not with data because we don't have the actual data set. They've just given us a summary. And then the first mean, they tell us which one they want to go first because that will change the sign. Mu B minus mu A. So trucker route B minus trucker route A. So I think that means for StatCrunch you want to put trucker route B first, because it's supposed to be the top minus the bottom. So it has an average of 51 with a standard deviation of 2. Then they said they took 20 truckers. And the second group was an average of 49, because remember it's B minus A here. 49, standard deviation of 3. I think this is set up to come out nicely by hand too. We don't want to pool. We don't want to pool the variances unless there's a good reason to think that they are coming from some sort of similar population where the variances would be equal. They're different enough. There's 3 and there's 2. We'd have to do a test to see whether they are different. And that's not what the question's indicating for us to do. So, and it's a confidence interval we want to calculate. And then if we hit compute, which is off screen here, a little to the right, I've got my lower bound and upper bound. So how many decimal places do they want? 2 decimal places, so this one rounds up to 0.36. The other one, 3.64. And if this is wrong, I'm just going to switch them, but no, okay. I would just switch the data because maybe they want, the sign would be different if you did mu A minus mu B, that's all. Choose the correct answer below. Part B, the question is, does the result provide sufficient evidence? It does, because 0 is not within this interval. If these two could be the same, then subtracting mu B by mu A would make 0 be in this interval. So 0 is not within this interval. So that means that there is some sort of statistical difference. If they were the same, then 0 would be a possibility. But our confidence interval is saying 0 is not a possibility. So does it provide sufficient evidence to conclude the company will save time? Yes. Which one of these is right, though? There's 3 options. The confidence interval does not contain 0, so it's not that one. Yes, this one's right. Wait, route B was a mean of 51. No, route B is slower. Route A is faster on average, right? Route A had an average of 49. Route B had an average of 51. So it's not that B is faster. It's that A is faster because they have a smaller time. Okay, I think that's it.